Welcome to part 3 of Competency 5. In this video, we will work with transformations. Okay, before we begin, I recommend that you take a quick picture of these transformations. So given a function, f of x, now we're calling it the parent function, really should say that that's the original function. It all depends. And as we work through these, you'll see what I mean. Regardless, you're going to start out with f of x and you're going to transform it, meaning you're either going to shift it up, shift it down, right, or left. So if you don't have these in your notes, I'd snip it, take a picture with your phone, whatever you need to do. Okay, number one, what is the equation of g? If the graph of f of x equals x to the third is shifted down 2 units, downward 2 units. So down 2 units is minus 2. Go up and look, and that is shifting down. That's the second one. So the entire function, you just subtract 2. So that is option B. Okay? All right, now we don't have a graphing calculator where we could actually graph both of these. So this is a situation where you really need to understand and know these. Okay. All right, so let's go to number 2. And it says, what is the equation of g of x if the function of same function, f of x equals x to the third, is shifted 4 units to the right? Well, that's the last one. It's still on our screen. Okay, well, what we're doing is we're taking the x, and to the right we subtract whatever that is. Let's see, that says 4 units. So that would be x minus the 4. Okay, but it's within the parentheses. Well, obviously A and B do not satisfy. Now, here's the thing. We have C and D, and we need to figure out what this should look like. Well, this is what it should look like. I mean, I'm not going to work the whole thing out. I mean, that may sound lazy to you, but all you really need to do is this. Write it, jot it down really quick, okay? And look at the beginning. So I have x times x times x. That's the first term. That's x to the third. Well, C and D both have that. Well, that's check and more check. Now what do we need? We need -4 times -4, -4. That would be these last terms here. Okay? All right, so let's put that in the calculator. So I'm going to open up a parentheses and put in -4. And if you've watched other videos with me, remember you really need to do that. Don't just put the negative out in front and then say 4 to the third. Okay, so we're doing this 4 times. 1, 2, 1, 2, 3. So that's carried up to the third, enter. There you go. We need the negative, so that's option D. If you're just dying to follow that through, knock yourself out. I wouldn't personally. You could to see what would happen, okay? All right, but remember, you're taking a test. And if you know your properties and your rules, you're going to understand that no matter what you do, you have to have -64 as this last term. It just has to happen. Okay? All right, let's go to number 3. Number 3, which of the following represents the graph of g of x if the graph of f of x equals x squared is shifted 1 unit up and 3 units to the left? Okay, let's get our highlighter out here. Actually, I'm going to use the green. That way we can actually see it. So we need 1 unit up. So I'm going to check each of these. Well, obviously, we can eliminate 2 of them right now. B and C shift down. Okay, so that isn't going to work. All right, now we need left. We need 3 units to the left. And obviously we need to know our right from our left, okay? Left would be this way. I don't see that shift in A. However, 1, 2, 3. It's satisfied in D. A obviously shifted the wrong direction, and we need D. Okay, now let's go up and see what they're talking about here. Oh, we got something else going on here. They're going to prepare us for the next question. Okay, all right, so take a picture of this, stop the video, write it down. Again, just have it off to the side, but let's talk about this. If an original function, f of x, is reflected about the x-axis, that means that we are subtracting, we are putting a negative in front of the entire thing. Or more precise, we are saying -1 times every single term in that f of x, okay? And then for reflecting over the y-axis, it's not a -1 times the entire equation. That is that we do what you see here. You have to take and put a negative, oh, let me put -1 there. To be precise, we need to say -1 times every single x, but only the x's, okay? Other constants remain as the definition of constant is. You don't change them, okay? All right, so let's move on to that next question and see how this works. Number 4, what is the equation for k of x if the graph of f of x equals x to the third is reflected about the x-axis? And now, if you remember the rule, if you are reflecting about x, everything in your given function must be multiplied by -1. Well, everything in our function is only one term. So, that being said, option A is the only one that we can select because B doesn't follow the rule. Negative exponent, we never said anything about that. Same thing with C. They've just kind of, when you say everything, well, I should say every term, not the exponent, okay? And then I'm not sure what's going on with D. I would say that question is just testing your basic knowledge of the property and the rules and properties, both, okay? All right, so let's look at 5. Given the function f of x equals x squared plus x plus 1, which of the following represents n of x that reflects f of x about the x-axis? Okay, we're going to do the same thing. Take the entire f of x and multiply it by the -1. Well, what does that give us? Well, everything needs to be negative. -x squared and -x and -1. It all started out positive. Now each term must be negative, okay? Looking around, well, that gets rid of B and C. C really doesn't make sense to me. Okay, and then, of course, A, the other two terms aren't negative, so we are left with D. All right, let's look at number 6. Given the function, oh, same function, x squared plus x plus 1, which of the following represents h of x that reflects f of x about the y-axis? Okay, remember this is different. You have to take each x and then multiply that by the -1, okay? That is going to result in something different, okay? So let's see, -1, and then we have an x, and then the constant of +1 stays plus. And because of that rule, particular rule and property, okay, combining the properties in the rule, Okay, either way, we know we have to have a positive here at the end. That last term of 1 plus 1 must remain. So this eliminates C and D for us. Now let's see what happens here. Well, the middle term, yeah, that's going to be negative x. Okay, well, I'm looking at B, but we need to verify. Okay, so what happens with when you have this? Let's see, negative x squared. Well, I'm going to go ahead and write this out here. That becomes negative, this becomes positive. This negative x times negative x, you square that negative x, you just get x squared, okay? So that verifies B and definitely eliminates A. All right, now let's look at number 7. Number 7, each week a small company earned a profit by selling handbags. The weekly profit P from selling X handbags is modeled by the function P of X equals negative 0.5x squared plus 40x minus 300. Based on the model, what was the maximum weekly profit in dollars that the company could have earned last year? And I do believe when they say last year, they really should have said each week last year. Okay? I kind of disagree with this particular question. But either way, let's take a look at what we have. It doesn't matter. We need to pop this in our calculator and realize what we're looking for. Now, sometimes, only sometimes, mind you, we can look at this middle term and it will help us out. Okay? But let's pop that in our table. Okay, so let's push table, clear out whatever we have there, and type in exactly what you see. Negative 0.5x squared. Okay, it arrows over for us automatically. Plus 40x. Oops. That should be x, not store. And then minus 300. Okay, push enter. Yeah, I'm going to start at 0. And I know I need whole numbers because I'm looking at my ABCD options and they are whole dollar values. Okay. Remember, we're looking for dollars. So it's obviously been rounded for us, or we could have an exact answer. I don't know. Okay. Looks like for the most part, we have a good setup. Okay. But which way do we go? Well, notice how 0, negative 3, that's a negative value. We want everything that is above 0 on this right-hand side for my y's. So I really would have to arrow down until I get that, okay? And then once I get there, I'm going to have to figure out what my maximum is because this is a quadratic going down, okay? So somewhere over here, going to this positive direction from where I had my negatives. Okay. I need to find that. I need to keep going until I find this value of x where I've got that max. Okay. Well, I can kind of see that if I arrow down carefully. Okay. I might have to arrow a while. Okay, it's still going up. You're looking at the right-hand side. Now, notice we got to 300 here at 20. So that'd be $300, and that is our A option. Well, let's go to the next one. It's still going up. So A, 300, is not a maximum because we're still climbing. Okay, so we're still going up on that left side of our equation, our curve. Okay, so let's keep going until we see the next thing, if it even gives us a 450. Okay, we're still going up, up. Oops, I went the wrong direction. Up. There's our 450. That might be the maximum. Let's see if it goes down when we go to 31. Nope, it goes up. So it can't be 450. Now keep going. It's still going up, still going up. Yep, yep. Mm-hmm. And there's our 500. Is that our maximum? Well, let's see what happens when we go to 41. Awesome. It goes back down so to 499 and 50 cents. Okay? So that means option C is what we need. Okay? So we're going down. So we should see a decline from here on as we arrow down. Going down, going down. Yep, yep. Definitely. So we never see $700. We never go up to 700. So D can be marked out. Okay. All right. Now I said, hey, sometimes this middle term will help us. We'll go back and take a look. Where were we? X equals 40. So if we had just tried to do the ask here, okay, go see how I highlighted ask X. So then let's enter. And let's clear out. We can delete everything here, okay? And then just type in 40 and it would have given us 500. But even though it did that, we can't tell if it's a maximum or not. It just says, hey, it's a value, okay? So that's why I didn't do it, right? There are ways, I mean, we could have just popped to that by using it, but that ask X doesn't work, okay? All right. So at least we knew where we could begin. So let's try that. See how I have start at 40? Then I can go back and go back to auto and go okay. And it started at 40 and then we could arrow up and test it, okay? So the ask doesn't always work for these. All right, let's look at number 8 and hopefully number 9. Okay. All right. Mr. Smith is a sales associate, excuse me, at a jewelry store. His total weekly earnings consist of a wage of $10 per hour plus a 10% commission on his total sales for the week. On his first week, Mr. Smith worked 30 hours and had a total sales of X dollars. Which of the following represents his total weekly earnings Y in dollars for that week? Okay, so let's write out this first bit. This is what they say to use as your recipe. There's our recipe. Now, they do give us pieces of our recipe. So we have $10 times the hours plus a 10% commission, okay, times I don't know how many dollars. Okay. So they said, hey, go ahead, or rather, we'll give you how many hours he worked. Now we have something to look at. We have 10 times our 30 plus a 10% unknown X in dollars. And I got that from right here, right out of our reading. Now let's go and take a look. Well, the 10x is misleading. We need a percent on that. And 10 really should go with a $10 per hour. And I don't like that 1% right there. I don't know where they're getting that from because that's not the hours. So I don't like A. Let's look at B. Uh, okay. What if we multiplied 10 times 30? Okay, and I'm going to go back. And I don't like to do everything in my head when I'm taking a test or teaching. So that is 300. Okay? Great, that's 300. Well, what about this 10%? What should that look like? Okay? Well, let's put that in the calculator also. So 10, go second and open parentheses because we're telling the calculator, hey, This is 10%. I'm going to push enter and it automatically says, well, that's the percent. So we should have plus 0.1x. And we do in option B. Now, C and D, let's think this out. Would they make sense? No, because here 1% of 300, that would be taking, it wouldn't be giving him the full amount of money for his 30 hours of work. So I don't like C at all. And then let's look at D. Well, I'm not sure about this. I think that would inflate what he took home. So that's not an accurate equation either. I mean, I agree with the 30 times 10, but this is saying you take 1% of 30, then times his sales. So that would inflate his commission. So that would be wishing for more than you'd actually have on your paycheck, right? Okay. So now we have verified B. Let's look at number 9. In the XY plane, segment AB is bisected by CD, and the coordinates of the points for the intersection are -2, -3. If the coordinates of A are -8, -1, what are the coordinates of point B? Oh my goodness. Okay. Well, try to sketch that. You know, I would say draw it and let's look at what we're looking at. When I see B all in the one, two, third quadrant. Okay. So this is what I would do. I would sketch it on the paper that they give me in my test. And if I don't have scratch paper, I would ask for it. If they haven't provided it, I'd raise my hand real quick. Okay. All right. Now, especially if you're taking one of those practice tests, that's a little different. Those practice tests at the university, definitely they should give you at least one piece of scratch paper before you go in because you can't write on the test. And if it's computer based, you definitely need it. And if they're nice enough to give you graph paper, ooh, you're set. Okay, so I have 0 here. Now, please note, I'm sketching this, okay? I'm going to look over here and I'm going to say -8 and then -1, okay? So here, let me get this out of the way here. Let me put a dot there. Okay, remember this is my origin. So my dot will be here, all right? And I'm going to say that this is -8. Okay, now my intersection will be at -2, -3. So, interesting. Okay, maybe let's put it over here. Yeah. Remember, still a sketch. -2. So I'm going to say that this is -2 and -3. So let's put the next dot, let's say right here. Obviously, my line going through will be negative. Okay. So a dot, fill that in. Okay. So I'll draw or highlight. Now let's draw it. Pretend like I can draw. Okay. That's very good. Good enough to get my point across, though. So what am I going to do? From 1 to 2, I go down 2 and then obviously over 6. So this is 2 and this is 6. And that is an intersection. Okay, so that's going to be a midpoint. Okay, so then if I continue, okay, here, B, this is A. I make this nice and big. This is A because A was -8, -1. That's A. So if I continue from this midpoint right here, -2, -3, and I follow that pattern of down 2 And over 6, okay, where will I be? Okay, and I'm sure, yeah, you bet you can do this mathematically, all kinds of other things. I'm not feeling it today. You understand. Okay, so I'm going to go 2 more negative. Okay, let me set this up here. From my midpoint, okay, I'm at -2, -3. I want to go 2 more negative. I'm going to go down 2, down 2. So another 2 negative means negative. Oh, I'm sorry, down 2. Ooh, that's here. Took me a second to think about that. Let's get rid of that. Okay. All right. Sorry about that. You're probably going, wait a minute, you're putting that on the wrong one. Okay. If I have -3 and I add another -2 on, I'm looking at -5 for my y. Okay. Well, then I would mark out C and D. Okay. Now, if I go to the right 6, okay, and I'm at -2, then I have to add on another 6. So +6 gives me 4 for my X, and that gives me option B. Great. Okay, like I said, it's easiest to draw it. I know there are other ways. I wasn't feeling it. Call me wrong, but there you go. At least you get to the answer, right? Okay. All right. So this is the last video. Sorry, last question in this video. Okay. Thank you so much for watching and making it to the end and putting up with me when I make little errors and I'm not thinking. At least this is how I need to think. And it's easy to be incorrect or get tired. All right. Thank you for watching and subscribing and liking and sharing. You guys are awesome. Happy testing.